This is Miss Goodwin, and today we are covering Objective 2.3, which is about triangle properties. Today's objective is that we can use triangle properties such as the angle-sum theorem, exterior angle theorems, and isosceles triangle theorems to solve for missing measurements. So let's go ahead and get started by looking at what some of these theorems mean. The first theorem we are covering today is the angle-sum theorem, also sometimes known as the triangle sum theorem. And this basically says that all three angles in a triangle add up to 180 degrees. So in the triangle we have three angles. We'll call them A, B, and C. If you add these all together, you will get 180 degrees. Now our next theorems are the exterior angle theorems, but first let's look at what an exterior angle is. Exterior angles are formed by any side of the triangle, or really any polygon, and the extension of its adjacent side. So if we look here, and let's say we're looking at this right here, I'm going to take this bottom side and stretch it out, and now I have an exterior angle. I can also extend this side out, and that's another exterior angle. And same here. Extend that side out, pretend they line up perfectly, and this is our exterior angle. We can also go the other way like this. Okay, so those are exterior angles. Now we have two theorems to go with that. The exterior angle is equal to the sum of both. Incorrect, not both. The exterior angle is equal to the sum of the opposite interior angles. And this is in case of a triangle specifically. So let's say in this little picture here, we call these A, B, C, and we're just going to focus on this red one out here, E. Okay. We can say that angle E is equal to the sum of B plus C. So just take the opposite angles and add them together. E is also equal to 180 minus the interior angle it is adjacent to, in this case, A. So both of these are true for the exterior angle. Another fact about exterior angles is that all of them, no matter the shape, will add up to 360 degrees. So that is exterior angles. Let's look at the isosceles triangle theorem. Actually, before we do that, we're going to look at the different types of triangles. So the first type of triangle is a scalene triangle. And a scalene triangle is where all sides are different lengths. So like in this example I just drew here, all three sides are different lengths. Isosceles triangles have two congruent sides. And we can usually use these little tick marks to indicate that these sides are congruent or equal. And the last The third type of triangle is an equilateral triangle, which you could probably figure out from the name. All three sides are congruent. So all three sides are the same length. Now, all of these were describing the triangles by their sides. On the next page, we're going to go look at how to describe them by angles. So now you might recognize some of these terms: acute, obtuse, and right. And we use those to describe triangles as well based on their angles. So an acute triangle is where all three angles in the triangle are acute, which remember means less than 90 degrees. Now, all triangles are going to have at least two acute angles, but it's that third angle that determines what type it is. So for an example, an obtuse triangle has one angle that is obtuse or greater than 90 degrees. And it might look something like this. This is just an example. Let's say this angle is 135 degrees. These two angles are going to be less than 90, whatever they are. And last but not least, we have a right triangle, which, as the name implies, we have one angle that is a right angle or equal to 90 degrees. And it might look something like this. And we can use that little square in the corner to say, hey, this is a right triangle. So now that we've looked at the different types of triangles, we can go back to the previous page and cover the isosceles triangle theorem. So the isosceles triangle theorem is where when you have two sides of a triangle that are congruent, then we can say that the opposite interior angles, also known as the base angles, are congruent as well. So if these two sides are the same length, like let's say they're both 5 inches, then these two angles are congruent. My bad. Okay. So those are the 3 theorems that we're going to need to kind of solve these problems. Let's go ahead and look at the level 1 questions now. So level 1 wants us to find all of the missing angles. So this first triangle, I could see that we're just given 3 interior angles, so we're going to use the angle sum theorem. I'm going to shorthand that. So we could say 42 degrees plus 26 degrees plus x, our unknown, is equal to 180. Add 42 and 26 together to get 68 plus x equals 180. I'm going to subtract 68 from both sides. To get x alone. And x is equal to 112 degrees. And you are done. So this happens to be an obtuse triangle. As we can see, both of these interior angles are acute, but this x is obtuse, as we just calculated. Let's look at another one. So I see here we have this little square, which tells me this is 90 degrees. So we already know this is a right triangle. Now let's find x. And we're going to use the angle sum theorem again. So 90 plus 48 plus x equals 180. 90 plus 48 gives you 138 plus x equals 180. Subtract 138 from both sides. And we get x equals 42 degrees. So our missing angle is 42 degrees. Let's look at our last level 1 question. Again, angle-sum theorem. So all 3 of these angles will equal 180 degrees. So let's add them together. 48 plus 77 plus x equals 180. Add these two together, and 48 plus 77 is 125 degrees. Plus x equals 180. Subtract 125 from both sides of the equal sign. That cancels out, leaving us with x equals 55 degrees. So because this angle is 55 degrees, we know this is an acute triangle. Let's start looking at some level 2 questions. So now level 2, we're going to get to work with a few more theorems. This first one has a triangle with a 50-degree angle, and we are given that these two sides are congruent based on the tick marks, indicating we're going to use the isosceles triangle theorem. So if these two sides are congruent, then we know these two angles are also congruent. So let's call them both x. So we get 50 plus x equals 180. This is from the angle-sum theorem. So we're using both of these. I can combine these x's together to get 50 plus 2x equals 180. Now I'm going to subtract 50 from both sides. That gives me 2x equals 130. Now to get x alone, we have to divide both sides by 2. And we can see x is equal to 65 degrees. So both of these base angles are 65 degrees. Let's look at the next one. Okay, so first I see this is a 90-degree angle. And we have an exterior angle here. And I'm going to abbreviate that to EXT. So there are two ways you could solve this. I'm going to use the exterior angle theorem property, which says that this exterior angle is going to be equal to the sum of these two angles. So 131 equals 90 plus x. To get x alone, I'm just going to subtract 90 from both sides. And we are left with 41 equals x. So this angle here is 41 degrees. Now you could also find this angle here by doing 180 minus 131, and that would get you 49 degrees. And then use the angle-sum theorem. Both are perfectly applicable to this situation. Let's look at our last one here, and it's more of the same. We have an exterior angle here, a 16-degree angle, and an x here. I'm going to show you how to do this doing the angle-sum theorem, but either of these methods will work. So let's find this angle first by doing 180 minus 64 degrees. That will give us 116 degrees. And now we can use the angle-sum theorem to solve for x. So 116 plus 16 plus x equals 180. Add these two together to get 132 plus x equals 180. Subtract 132 from both sides, and we get x equals 48 degrees. And you are done. Okay? So again, both methods will work for when you have an exterior angle. Now let's look at some level 3 problems. Okay, so we are given that in triangle HIJ, we are given that the measure of angle H is equal to x plus 14. The measure of angle I is 5x plus 5. And the measure of angle J is 3x minus 1. And we want to know what is the value of x. So first thing I'm going to do is draw our triangle. This is an optional step, but I find that it helps me visualize what I'm looking for. So in angle, we have angle H is I and J, so I'm just going to label them H, I, J. Doesn't matter where you put them, but just put them. Angle H is x plus 14, so that is this right here. I did not leave myself a lot of room, so I'm just going to do that little swoop there. Angle I is 5x plus 5. And angle J is 3x minus 1. Okay, I can see I'm given 3 interior angles, so I'm going to use the angle-sum theorem and just that. So we don't have to worry about exterior angles or the isosceles triangles. We just have to add all these together. So x plus 14 plus 5x plus 5 plus 3x minus 1 and set it equal to 180 and then solve for x. So first I'm going to combine like terms, so everything with an x is going to be added together. So x plus 5x plus 3x gives us 9x. Now add everything without an x together, so 14 plus 5 minus 1, and that will give us plus 18 equals 180. Subtract 18 from both sides, we get 9x equals 162 degrees. Divide both sides by 9, and we get x equals 18. And that is just x, that is not your final angle. So if you were asked to find a specific angle, you would have to go and plug that back in. I believe that's a level 4 question, so we'll see that in a moment. Okay, so let's look at this next level 3 question, because we are done with this, because that is all we were asked for. All right, woo, I see the word extended. That is telling us that we're probably going to have an exterior angle. So let's see. We are given triangle NOP. Okay. The line NP is extended through point P to point Q. So there's some point Q out here that this line is stretched through. P and O is 3x plus 12. So that's P and O. 3x plus 12. And then NOP is 3x plus 15. That is NOP. and OPQ, that is this exterior angle here, is 8x plus 17. We want to know what's the value of x. So we are given two opposing angles and not an interior, we are given an exterior angle. That hints to me that we're going to use one of our exterior angle theorems. In this case, the exterior is equal to the sum of both the interior. So we could say 8x plus 17, which is our exterior, equals the sum of both of the interiors. So 3x plus 15 plus 3x plus 12. On the right hand side, I'm going to start combining like terms. So we get 3x plus 3x. And that gives us 6x. Now 15 plus 12 gives us plus 27. And that is still equal to 8x plus 17. Now I want to subtract 6x to the left side, so we have our variables all on one side. Now I'm going to subtract 17 from both sides to give us 2x equals 10. Divide both sides by 2, we get x equals 5. And we are done there because all we were looking for is x. Okay. Now on to our last problem, which is level 4. Okay. This time we are given the picture and we need to find 5 different pieces, but we can do that pretty easily. I see we have an exterior angle and 2 interior angles. So the first thing we're going to solve for is x using the exterior angle theorem. Okay, so we get 6x plus 11 equals 2x plus 9 plus 2x plus 14. Let's add both of our x's on the right side to get 4x, and 9 plus 14 to give us plus 23. That is equal to 11, or 6x plus 11. Now subtract 4x from both sides to give us 2x plus 11 equals 23. Subtract 11 from both sides, we get 2x equals 12. Divide both sides by 2, we get x equals 6. So now we know x is equal to 6. So now we have 4 different angles to find. First one is WXY, so that's WXY. Nope, that's not WXY. WXY, right here. And we can see that that is equal to 6x plus 11. So now we're just going to plug in our x value of 6 into that. So we get 6 times 6 plus 11. That becomes 36 plus 11, which is 47 degrees. So angle WXY is 47 degrees. Now we need to find WXV. WXV, which is right here. And because this is a straight line, I can see we're going to just treat these as supplementary angles and subtract our known from 180. So WXV is equal to 180 minus angle WXY, which becomes 180 minus 47, which is 180, or nope, that is not 180, that is 133 degrees. So this angle right here is 133. Now we need to find XWV, which is the 2x plus 9 up here. Okay, so same deal, plug 6 in for x. 2 times 6 plus 9, that gives us 12 plus 9, and that is 21 degrees. Okay. And now our last bit is WVX, which is this angle right here, 2x plus 14. So just like before, plug that 6 in for x. We get 2 times 6, which is 12, plus 14. 12 plus 14 gives us 26 degrees. We are done with this problem. And if you wanted to check your work, just make sure these three add up to 180. So 3 plus 1 plus 6 gives us a 0, carry the 1 over. 1 plus 3 plus 2 does give us 8. 1 plus nothing gives us 1. So yep, all three of these are 180 degrees, just like a triangle should be. So that is it for this lesson. So if you have any questions, feel free to let me know. And go ahead and get started on some of these never mind, it's done. So go ahead and get started on the Desmos activity, and I'll see you next time. Bye!